So in last class, we have seen the fundamentals of supercharging, turbocharging. We also seen the fixed geometry, wastegate, turbocharger, variable geometry, turbocharger. So today we will be seeing the turbocharger matching and then the compressor and turbine efficiency. So we have seen volumetric efficiency, what is the airflow requirement last week. We also seen the supercharging, turbocharging principle, why we need to have the supercharger, turbocharger, and different types of supercharger we have seen, and what is the disadvantage of supercharger, and what are the key components of turbocharger we have seen. We also seen the layout of the turbocharger. We have seen the limitations of turbocharger where you have some turbo lag, and how that aspect ratio will be overcome with the help of the variable geometry turbocharger. And we have seen the need, why we need to have GT or shortly called as variable geometry turbocharger. We have compared the variable geometry turbocharger with the conventional turbocharger. So now we will see the turbocharger matching and then the compressor and turbine efficiency. So we'll see the compressor mapping. So the x-axis is nothing but the mass airflow rate, okay, and y-axis is nothing but the pressure ratio. The pressure ratio is basically the outlet pressure to that of the ratio between the outlet pressure to that of the inlet pressure. The inlet pressure, the mass flow rate of the air which is entering into the cylinder, and the exhaust pressure is basically the exhaust gas flow which is coming out from the exhaust system. So that ratio you call that as a pressure ratio. And you see here, I told you the turbine RPM will be close to 1 lakh to 1,50,000 RPM, depending upon the speed and then the airflow rate and then the mass flow rate of the gas as well. You see here, this indicates the RPM of the turbine, and this the percentage. Okay, the percentage indicates the percentage of the efficiency of the compressor. Okay, and again you have a limit called surge limit. This is the operating threshold limit for say for example, if the flow rate, if the mass flow rate of the air is said to be 1.5, and if the pressure ratio is 2, then you need to select a value. It will come somewhere here, and you need to select a value considering about the surge limit. Okay, I told the surge limit is the operating zone where you need to select between the surge limit and then this is the check final limit. Okay, so in between the surge limit and the check limit, you need to select the efficiency of the compressor and also the RPM at which the turbine needs to perform. So you see here, suppose if I selected the 2 as a pressure ratio and 1.5 as a flow rate, then you need to select the value straight away above the surge limit, and you will select something in the efficiency close to 75%. Okay, and accordingly, because you should not give overload to the compressor also. Suppose you select efficiency higher than what is required, then again you are giving excess load. You will also, even though the efficiency is going to be higher, but you are unnecessarily increasing the pressure, or you are unnecessarily increasing the flow rate, which is not required. So it's always essential to select the best required efficiency. Okay, too much efficiency is also not a viable one, as it will affect even though the performance we can meet, as it will affect the durability and then the lifetime of the turbocharger as well. And P1 is nothing but the inlet temperature, and P1 is nothing but the inlet pressure. I told the ratio, pressure ratio is basically the outlet pressure to the inlet pressure, and the air flow rate is the correct air flow rate. The flow rate is nothing but uh, the mass flow rate of the medium. So here the unit is kilogram per second, and n is nothing but the speed, okay, at which the turbine performs. Okay, so and T1 is nothing but the inlet temperature. And according to this, you need to select compressor mapping. And you see, it is very much important. You need the compressor and turbine engine matching, considering the efficiency. So we have seen the graphs showing the air flow rate and then the pressure ratio. So now we need to see how we are going to match the engine turbocharger turbine and also the compressor. So there's a procedure is there, and you need to go with that procedure. And you see here again there is one more graph showing the mass flow rate. So here the mass flow rate is nothing but the gas flow rate. Okay. Uh, uh, so the exhaust gas basically is consists of a thing where the flow rate strikes the turbine blade. And you see here again, you need to look at suppose if you find the pressure ratio 1.8 and the mass flow rate as 1.5, then you need to select the actual efficiency considering the relationship between the compressor and the turbo, and you need to select based on the temperature and also the fuel flow rate and also the mass flow rate. So here there is a big procedure. First, you need to consider the engine inlet conditions. Then, what you need to give is what you need to consider is you need to consider the engine volumetric efficiency. And again, basically the volumetric efficiency deals with the mass flow rate of the air. Okay, higher the mass flow rate, you get the higher volumetric efficiency. You need to determine the volumetric efficiency of the engine. You need to understand your inlet condition, then you need to calculate your volumetric efficiency, then mass flow rate of the air, and again accordingly you need to the speed of the turbine. According to the speed of the turbine, you need to see what is the speed of your compressor, and you need to map according to the pressure ratio and the flow rate, and you also need to consider what is the fuel flow from the engine map. And then again, you need to find out the exhaust temperature, engine exhaust temperature. So this is the inlet condition. Again, also look at the exhaust temperature, exhaust pressure. So if when you get the temperature, you will also get pressure. So exhaust pressure divided by the inlet pressure, you get the pressure ratio. And again, you need to find out what is the turbine speed, and then based on the turbine speed and also the mass flow rate, you can also get out what is the flow rate in the x-axis. So according to this, you can select the efficiency percentage, and then what you is finally you need to determine the turbine power from the turbine on mapping, and how much power you're going to get. Basically, that this also you can obtain it, and finally you need to do the iterations considering all the input condition, outlet condition, and also the efficiency